Next, we have the argument form of the pure hypothetical syllogism. Okay, so the pure hypothetical syllogism is any uniform substitution instance using simple or compound statements of the argument form P then Q, Q then R, P then R. Okay, so here is the actual general form of the pure hypothetical syllogism. Okay, and notice the structure here. What you have here are all conditional statements. Okay, so all the premises as well as the conclusion are conditional statements. Okay, not only that, but notice what's going on in each of the premises and the conclusion. And notice here you'll have a specific pattern in which the antecedents and the consequence of each of these conditional statements will take. Okay, first, for this statement here, the second premise, I'm going to start with that, you'll have the antecedent of this statement will be the consequent of the other conditional statement that is a premise. Okay? Then, for the conclusion, okay, you'll have the antecedent of the first conditional statement that was the premise and the consequent of the second conditional statement that was a premise. So if you see here, there's a specific order in which the antecedents and the consequence of each of those conditional statements will take. For the first conditional statement, you'll have its consequent being the antecedent of the second conditional statement. Okay? And then for the conclusion, you'll have the antecedent of the first conditional statement that is a premise, and the consequent that is the consequent of the second conditional statement as the premise. Okay? Now, when you think about an argument like this in ordinary language, you can kind of consider the reasoning to be somewhat mathematical. Okay? The relationship, however, is not mathematical. However, you can think of the kind of reasoning analogous to mathematical reasoning. What do I mean? Well, consider this. Let's think about this structure or form in terms of ordinary language. Okay? So you have, let's say, the statement H again, which is Socrates was human. Okay? And you have the statement M again, which is that Socrates was mortal. Okay? And then you have the statement D, okay, which will be that Socrates will die. Okay? So let's say you have these three statements here. And we've substituted P with H. Okay? So here we have P being H. So we put H here. And we'll also put H here where the P occurs in the conclusion. Okay? And then we have M being Q. Okay? So M will be here. And M will also be here in the second premise. Okay? And then we have D as R. Okay? So the argument will be if H then M, if M then D, if H then D. Okay? So this argument in ordinary language would read, if Socrates was human, then he was mortal. Socrates was mortal, then Socrates will die. And the conclusion will be, if Socrates was human, then Socrates will die. Notice how, when you think about this argument in ordinary language, it makes complete sense that if the premises were true, the conclusion would follow. Okay? If it were true that if Socrates was human, then he was mortal, and it was also true that if Socrates was mortal, then Socrates will die, it will follow, okay? It will definitely be true that if Socrates was human, then Socrates will die. Okay? Now, you can think of this type of reasoning in terms of mathematics as well. However, note that in mathematics, the reasoning is different than here where you have conditional statements. However, you can kind of think about the relationship in the reasoning analogously. Okay? So if I said, look, 9 is greater than 3, okay? And then I tell you that 3 is greater than 2, okay? From these two premises of mathematics, I can conclude that 9 is greater than 2, okay? So notice how here the structure is very similar to the structure that's going on here, except the reasoning that's involved here is that of greater than, okay? Whereas the reasoning involved here is that of a conditional statement, okay? So antecedent, consequent, necessary, and sufficient relationship, okay? But notice that the structure is very similar. You have the 9 here, okay, as the 9 here in the conclusion of this mathematical argument, okay? And you have the 2 here, which is the 2 here of the conclusion of the mathematical argument. Just like here, you have the P and the P here, okay? Just like the 9s. And then here you have the R's, which are the R's here, just like the 2s. And what links these two together, okay, the P and the R here and the 9 and the 2 here, are these statements in between, okay, that for the argument of the pure hypothetical syllogism makes up the consequent of the first premise and the antecedent of the second premise. So notice that you'll have kind of a similar pattern of reasoning, okay? Now, I'm going to erase all of this because it's a little bit messy. Okay, so let's look at some examples here of arguments that take the form of the pure hypothetical syllogism, okay? So here's one example here. So this is an argument that takes the form of a pure hypothetical syllogism. How do we know that? Well, first we know that all 3 statements, both premises and conclusion, are conditional statements, okay? So notice this first statement here, which is the first premise, is a conditional statement because the main operator is the conditional horseshoe. The largest components that make up this conditional statement is everything that's in the bracket here and the negation S, okay? And then here in this second statement, we also have the conditional horseshoe as the main operator, and the largest components that make up this statement here is the negation S and the M, okay? Then here we have, again, a conditional statement because we have the main operator being a conditional horseshoe. And the largest component that makes up these statements are everything in the brackets here and the M. So we have 3 conditional statements, okay? But just because you have 3 conditional statements doesn't mean that you automatically have a pure hypothetical syllogism, okay? You also have to make sure that the P, Q's, and R's are in this order, okay? So let's start with the P's. Notice here in this statement here, you have as the antecedent of this conditional statement, okay, G and C wedge P, okay? And all of this then we can say will be the P in this form here, okay? And notice we also have this statement here as the antecedent of the conditional statement that is in the conclusion. G dot C wedge P, okay? So we also have P occurring here. Then we also have, in this case here, we'll say this is going to be the Q, okay? And we have negation S as the Q, okay? And we also have negation S over here as the antecedent of the second premise, which is a conditional statement. So here's Q, okay? And notice how where the Q's are takes the same position that the Q's are here in this argument form, okay? Then here, where the M is, this will take up the position R takes, okay, in the argument form, and we also have M over here, which is again R, okay? So notice how the P's and the Q's and the R's occur in the exact same positions where you have the P's and the Q's and the R's occurring here in the argument form, okay? So this is why we have a pure hypothetical syllogism, okay? Let's look at this one here. Again, we have 3 conditional statements, and we know that because the conditional horseshoe makes up the main operator for all 3 statements, okay? This statement here, we have M wedge N as the antecedent, and here we have S wedge Q as the consequent. Here we have P wedge R as the antecedent, and here we have M wedge N as the consequent. And here we have PVR as the antecedent, and S wedge Q as the consequent, okay? Now if we look to the conclusion of this argument, and we say, look, we're going to make here, just like in the form, the antecedent of the conclusion will be P. Okay? And the consequent of the conclusion will be R. Okay? That means R is this statement here as well. Okay? And P will be the antecedent here of the second conditional statement. Okay? Then we have M wedge N here and M wedge N here. Okay? So the only letters that we have yet to distribute is the Q. Okay? And notice how M wedge N is the same statement as M wedge N here, okay? Except here you have it as the antecedent of this conditional statement, and here you have it as the consequent of the second conditional statement. So we can go ahead and give Q to both of these statements because they're the same statements, and we have yet to give a statement the statement variable Q, okay? So now notice how here we have it the case that the conclusion, okay, is P horseshoe R, okay? However, what's going on here is that although we have the P's and the Q's and the R's in the correct places, it's the premises that are in the wrong order. So here, Q horseshoe R is actually the second premise, okay? And P horseshoe Q is actually the first premise, okay? So all we have to do in order to make this look exactly like the structure or the form of the pure hypothetical syllogism is to simply flip the two premises, okay? And then we'll have it look exactly like this. However, you could switch these two premises back and forth and it wouldn't matter. It would still be a pure hypothetical syllogism as long as the premises in a specific order would match this form. Okay, so the order of the premises doesn't matter, okay? All that matters is that in a specific order, the form or the structure of that argument does match the form or the structure of the argument in question, okay? So here we have an example of a pure hypothetical syllogism, and here also we have an example of a pure hypothetical syllogism, except with this one, you just need to flip the first and second premises, okay? Let's now take a look at two argument forms that are not pure hypothetical syllogisms, okay? So here we have one here. Now, notice that this might look like a pure hypothetical syllogism, right? Why? Because all the statements are conditional statements. Here in the first statement, you have the conditional horseshoe being the main operator, bringing together the K, along with the L wedge tilde R. And then here in the second statement, you also have a horseshoe as the main operator, which brings together the L dot tilde R with the M, okay? And then the conclusion, you also have the main operator being the conditional horseshoe, which brings together the K with the M. Now also, you might say, well, look, the conclusion, if we give the K, okay, the statement variable P, and we give the M the statement variable R, then we can give the K here the statement variable P as well, and the statement M here the statement variable R as well. So then in this case, it's starting to look very similar to the argument form that you have here, right? You have three conditional statements, okay, and then you have the P and the P here, and you have the R and the R here, okay? However, if you look at the consequent of the first conditional statement, as well as the antecedent of the second conditional statement, you'll notice that they are actually different, okay? The consequent of the conditional statement in the first premise is L wedge tilde R, whereas the antecedent in the second premise is L dot tilde R. This means that these are two different statements that make up this conditional statement compared to this conditional statement, okay? So if you gave this consequent here the Q, you cannot give the Q statement variable to the antecedent here because this is a different statement compared to this statement here, okay? So this, you would have to give a different statement variable, for example, something like S, okay? So now if you look at this, although it might come really close, okay, to being a pure hypothetical syllogism, it is actually not a pure hypothetical syllogism because we do not have this statement here being the same as this statement here, okay? However, if we changed this statement here, so if we changed this antecedent here that makes up the conditional statement that is the second premise from a conjunction, which is its main operator here, into a wedge, okay, so that these two would be the same, so we change that into a wedge, okay, then these two here would be the same statements, okay? The consequent here of the first conditional statement will be the same as the antecedent here of the second conditional statement, which means we can actually then give this antecedent here of the second conditional statement the statement variable Q, okay? And then by doing so, this would become a pure hypothetical syllogism, okay? Because there's three statements that are all conditional statements, and all the P's and Q's and R's are basically in the exact same order that is given in the argument form of the pure hypothetical syllogism, okay? However, this argument as it was given was not given with that change, okay? So this here as it was given is a dot rather than a wedge, okay, which makes these two different statements, okay? The statement that makes up the consequent of this conditional statement here is different from the statement that makes up the antecedent of this conditional statement here, okay? So this is not an example of a pure hypothetical syllogism, okay? Let's look at this example here now. Notice again here you have three statements that are all conditional statements. So you have the conditional horseshoe as the main operator that brings together the component part of B wedge C with D wedge E, okay? Then you have this second statement here, which is the second premise of the conditional statement, that has a horseshoe as the main operator, which brings together the D with the F wedge G. And then for the conclusion, you also have the horseshoe as the main operator, which brings together the B wedge C with the F wedge G, okay? So now in this case, if again we look to the conclusion first and we said, okay, we're going to give the antecedent of the conclusion the statement variable P, and we're going to give the consequent of the conclusion the statement variable R, okay, just like in the form of the pure hypothetical syllogism, we have P and R being the conclusion. Then we would give here the consequent of the second premise, the same statement variable we gave here because they're the same exact statements, F wedge G, so this would become R. And here we would give the statement variable Q just like in the form, okay? So here in the premises, the one with the R will get the Q. So D would be Q, okay? Then here the antecedent of the first premise, okay, that is a conditional statement, will get the P as a statement variable because it is the same as the antecedent of the conclusion, B wedge C, okay, so they would both get P, okay? However, the consequent of this conditional statement, that is the first premise, would not get the same statement variable as the antecedent of the second conditional statement because they are different statements, okay? So here we only have D, whereas here we have D wedge E, okay? So here we would have to use a completely different statement variable because these are not the same statements. It would also not get the same statement variable as the R here, since these are two different statements, okay? Or the same statement variable as the P here because these are two different statements, okay? So let's give the statement variable S to that one here. And if we look now at the structure of this argument, you would see that this structure or form is different from this structure or form, okay? So notice, although it's the case that they both have three conditional statements, okay, and the conclusion has the P and the R, okay, and the second premise has the Q and the R, okay, it is not the case that the first premise has the P and the Q. Okay? Well, this has P and then S. Okay? So this also is not a pure hypothetical syllogism. So this here would differ in what's going on in the consequent of the first premise and the antecedent of the second premise. Okay? And so because of this difference, this would not be a pure hypothetical syllogism. Okay? Okay, so let's go ahead and take a look at another argument form, the disjunctive syllogism. Okay? So any uniform substitution instance using simple or compound statements of the argument form here will be a disjunctive syllogism. Okay? This is the general form or pattern for the disjunctive syllogism. And notice what you have here is one of the premises is a disjunction, okay, P wedge Q. Then the second premise is the negation of the first disjunct in the disjunction. So notice how here you have P wedge Q, and then the second premise is the negation P. Okay, it's the negation of that first disjunct. Okay, then the conclusion is the second disjunct, Q. Okay, so this reads something like in ordinary language, something like this. Okay, so let's say you have something like statement A, which is all apples are red. And then you have another statement B, all violets are blue. Okay? So let's say we replace the statement variable P with the statement A. And then we replace the statement variable Q with the statement B. Okay? Then in ordinary language, this argument would read, it's either the case that all apples are red or all violets are blue. It's not the case that all apples are red, so it is the case that all violets are blue. Okay? So this is the form of the disjunctive syllogism. Okay? Let's look at some other arguments that have the form of the disjunctive syllogism. So here's an argument that is a disjunctive syllogism, and notice that what you have in this argument, first of all, is one statement that is a premise, that is a disjunction. So here you have the disjunction wedge as the main operator, which brings together the R horseshoe P as one component and the S as another component. And then here you have as the second premise the negation of the statement R horseshoe P, and then as the conclusion you simply have S. Okay? So you have two premises here, one which is a disjunction and the other is a negation. Not only this, but notice how the negation is the negation of the first disjunct. So R horseshoe P takes the position of the P in the form, okay, so the P over here, and the S takes the position of the Q. In this sense, the P is the first disjunct in the disjunctive statement, and the negation is negating the R horseshoe P, which makes up the first disjunct in that disjunction. So this statement here is the negation of P, okay? And then the S is the other disjunct in the disjunction, which takes the position of the Q. So notice how this here actually has the form of the disjunctive syllogism. P wedge Q, not P, then Q, okay, as the conclusion. Here's another example of a disjunctive syllogism. Again, we have here a disjunction as the main operator, okay, and this brings together the G with the compound statement H dot R then S, okay? And then as the second premise, we have the negation of G, okay? And then as the conclusion, we have H dot R then S, okay? And again, notice that what's going on in these premises in the conclusion is that for the negation that is the second premise, what we have negated is the first disjunct of the disjunctive statement, which in this case will be P, and here the second disjunct will be Q. So in the second premise, we have the negation of P, which is G, which makes up the first disjunct P, okay? So P, P, okay? And here we have P, P, and then the negation. Here's the negation, okay? Then in the conclusion, we have the second disjunct being asserted, okay? So here we have H dot R, then S. And here again, we have H dot R, then S. And this was Q, so this would be Q as well. And we see now that this takes the form of the disjunctive syllogism. P wedge Q, P wedge Q, not P, Q, Q. Okay? Now here's an example that is not a disjunctive syllogism, although it may look like one. Okay? So notice that we do have here a disjunction as one of the premises, and this disjunction brings together F wedge G with H, okay? And we also have a negation that is the second premise, and here we have negation F. And then we have the assertion of one of the disjuncts, here H, as the conclusion, okay? Now notice how, although it's the case that here we have the Q, okay, so if this is Q here in the disjunction of the disjunctive statement that is here, then Q would be here as well since this is H, okay? However, what is going on here is problematic, okay? The first disjunct of the disjunction, which would be P in this case, okay, is F wedge G. However, what's being negated in the second premise is only F, okay? And so F wedge G would get a different statement variable compared to F, because these are two different statements, okay? Even though one composes the other, they're still different statements, okay? So here we can simply leave it as F, okay? So we'll give it the statement variable F, okay, lowercase f. So notice now this form or structure, okay, does not correspond with the form or structure given here. Whereas here you have P wedge Q, not P, so Q. Here you have P wedge Q, not F, so Q, okay? So this actually is not a disjunctive syllogism, okay? Now, if we were to change this statement here, negation F, to the negation of F wedge G, okay, then this would follow the form of the disjunctive syllogism, because we have not only a disjunction here, but in the second premise, we have the negation of the first disjunct in the first premise, okay? And then, as a conclusion, we have the assertion of the second disjunct in the first premise, okay? So then this, with this change, would be a disjunctive syllogism. However, the argument was not given like this. It was given like this, which makes it a completely different argument. And as such, it is not a disjunctive syllogism, okay? Okay. Let's look at our final form for the time being, okay? So here you have the constructive dilemma. A constructive dilemma is a uniform substitution instance using simple or compound statements of the argument form, which is this, okay? Now this is a little bit more complicated than all the other forms that we are looking at, okay? So here we have, as one of the premises, a conjunction. So the conjunction is the main operator here, okay? And it's the conjunction of two conditional statements. P then Q, okay? And R then S, okay? So P horseshoe Q, R horseshoe S, okay? And this is one statement, okay? Then as the second premise, we have a disjunction, P wedge R, okay? Now notice how this disjunction here, P wedge R, is going to have as its first disjunct the antecedent of the first conditional statement that makes up the conjunction of the first premise. And as its second disjunct, okay, the antecedent of the second conditional statement that makes up the first premise, which is a conditional statement. Okay, and this must be the case, okay? The second premise must be the disjunction of the antecedent of the first conditional statement that makes up the conjunction of the first premise, and the antecedent of the second conditional statement that makes up the conjunction that is the first premise, okay? Then notice how for the conclusion, what you have is again a disjunction where the first disjunct is the consequent of the first conditional statement that makes up the first premise, which is a conjunction, and the second disjunct is the consequent of the second conditional statement that makes up the statement that is the first premise, okay? So this is the form of the constructive dilemma, okay? An easier way to kind of conceptualize the constructive dilemma is to kind of think of them as two modus ponens smushed together by a conjunction, okay? Let me show you. So notice here you have P horseshoe Q as the conditional statement that makes up half of this conjunction, okay? And here you have R horseshoe S as a conditional statement that makes up the other half of this conjunction, okay? Now, if you think about it here, you can see this part here, okay, as half of the constructive dilemma, okay, which is, in essence, a modus ponens. P then Q, P so Q, okay? And then you could think of this other half here as another modus ponens. R horseshoe S, R so S. So here you have, in essence, two modus ponens that are smushed together, okay? And they're being held together by, in the premises, a conjunction dot and a disjunction wedge, and in the conclusion, a disjunction wedge, okay? So if you'd like to, if this makes it easier, you can conceptualize the constructive dilemma as two modus ponens kind of smushed together, okay? Okay, so let's move on to an example of a constructive dilemma. So here is an example of a constructive dilemma, and notice that it's quite complicated, okay? Now, the first thing that you should note here is that you have a conjunction as one of the premises and a disjunction as another premise, okay? So here's the conjunction, okay, which brings together basically this, everything in the brackets, okay, as well as this, everything in these brackets. So these are the two largest components, okay? Not only this, but notice that what this conjunction is bringing together are two conditional statements. So notice that inside these brackets here,